Big data generated by people. How is it being used? We listed a number of challenges for using unstructured data generated by human activities. Now let's look at some of the emerging technologies to tackle these challenges and see some examples that turn unstructured data into valuable insights. Although unstructured data, especially the kind generated by people, has a number of challenges, the good news is that the business culture of today is shifting to tackle these challenges and take full advantage of such data. As it is often said, a challenge is a perfect opportunity. This is certainly the case for big data, and these challenges have created a tech industry of its own. This industry is mostly centered, or as we would say, layered or stacked, around a few fundamental open-source big data frameworks. New big data tools are designed from scratch to manage unstructured information and analyze it. A majority of these tools are based on an open-source big data framework called Hadoop. Hadoop is designed to support the processing of large data sets in a distributed computing environment. This definition would already give you a hint that it tackles the first challenge, namely the volume of unstructured information. Hadoop can handle big batches of distributed information, but most often there's a need for real-time processing of people-generated data like Twitter or Facebook updates. Financial compliance monitoring is another area where such real-time processing is needed, in particular to reduce market data. Social media and market data are two types of what we call high-velocity data. Storm and Spark are two other open-source frameworks that handle such real-time data generated at a fast rate. Both Storm and Spark can integrate data with any database or data storage technology. As we have emphasized before, unstructured data does not have a relational data model, so it doesn't generally fit into the traditional data warehouse model based on relational databases. Data warehouses are central repositories of integrated data from one or more sources. The data that gets stored in warehouses gets extracted from multiple sources. It gets transformed into a common structured form, and it gets loaded into the central database for use by workers creating analytical reports throughout an enterprise. This extract, transform, load process is commonly called ETL. This approach was fairly standard in enterprise data systems until recently. As you probably noticed, it is fairly static and does not fit well with today's dynamic big data world. So how do today's businesses get around this problem? Many businesses today are using a hybrid approach in which their smaller structured data remains in their relational databases and large unstructured data sets get stored in NoSQL databases in the cloud. NoSQL data technologies are based on non-relational concepts and provide data storage options, typically on computing clouds, beyond the traditional relational database-centered warehouses. The main advantage of using NoSQL solutions is their ability to organize the data for scalable access to fit the problem and objectives pertaining to how the data will be used. For example, if the data will be used in an analysis to find connections between datasets, then the best solution is a graph database. Neo4j is an example of a graph database. Graph networks is a topic that the Graph Analytics course later in this specialization will explain in depth. If the data will be best accessed using key-value pairs, like a search engine scenario, the best solution is probably a dedicated key-value pair database. Cassandra is an example of a key-value database. These and many other types of NoSQL systems will be explained further in Course 2. So, we are now confident that there are emerging technologies for individual challenges to manage people-generated unstructured data. But how does one take advantage of these to generate value? As we saw, big data must pass through a series of steps before it generates value, namely data access, storage, cleaning, and analysis. One approach to solve this problem is to run each stage as a different layer and use tools available to fit the problem at hand and scale analytical solutions to big data. In coming lectures, we will see important tools that you can use to solve your big data problems in addition to the ones you have seen today. Now let's take a step back and remind ourselves what some of the value was. Remember how companies can listen to the real voice of customers using big data? It is this type of people-generated data that enabled it. Sentiment analysis analyzes social media and other data to find whether people associate positively or negatively with your business. Organizations are utilizing processing of personal data to understand the true preferences of their customers. Now let's take a fun quiz to guess how much Twitter data companies analyze every day to measure sentiment around their products. The answer is 12 terabytes a day. For comparison, you would need to listen continuously for 2 years to finish listening to 1 terabyte of music. Another example application area for people-generated data is customer behavior modeling and prediction. Amazon, Netflix, and a lot of other organizations use analytics to analyze preferences of their customers. Based on consumer behavior, organizations suggest better products to customers, and in turn, have happier customers and higher profits. Another application area where the value comes in the form of societal impact and social welfare is disaster management. As you have seen in my wildfire example, there are many types of big data that can help with disaster response. Data in the form of pictures and tweets helps facilitate a collective response to disaster situations, such as evacuations through the safest routes based on community feedback through social media. There are also networks that turn crowdsourcing and big data analytics into collective disaster response tools. The International Network of Crisis Mappers, also called Crisis Mappers Net, is the largest of such networks and includes an active international community of volunteers. Crisis Mappers use big data in the form of aerial and satellite imagery, participatory maps, and live Twitter app updates to analyze the data using geospatial platforms, advanced visualization, live simulation, and computational and statistical models. Once analyzed, the results get reported to rapid response and humanitarian agencies in the form of mobile and web applications. In 2015, right after the Nepal earthquake, Crisis Mappers crowdsourced the analysis of tweets and mainstream media to rapidly access disaster damage and needs, and to identify where humanitarian help is needed. This example is amazing and shows how big data can have huge impacts for social welfare in times of need. You can learn more about this story at the following link. As a summary, although there are challenges in working with unstructured, people-generated data at a scale and speed that applications demand, there are also emerging technologies and solutions that are being used by many applications to generate value from the rich source of information.